Hi there. Welcome to this lesson, which is an introduction to transformations. Please like this video if you find it helpful, subscribe to the channel for more math content, and drop a comment or question below to engage. Now, I am going to try to keep this portion of the lesson fairly short because we are going to have an embedded piece that I want you to click over to. We'll get to that in a little bit. First part of this is what are transformations? So we do have to plow through a decent amount of vocabulary. I looked up definitions, like where could I find definitions of transformations? And they're all very mathy, which means they're very precise, but not necessarily user-friendly. So if you're a student watching this, you want a definition you can wrap your head around. So what I did was I tried to condense it this way. Transformations are ways to move or alter an existing graph. So you start with a particular graph, and then you're going to move that graph around the coordinate plane or alter it in some way that is predictable. It's not going to change the foundational shape of it, but it might change some aspects of the shape. So transformations are just the different ways we can do that. Now, there are some transformations. I never studied this too much in geometry, but I know some geometry classes do, so you might be familiar with these words. One of the transformations that we do in a lot of detail is sliding, and the math word for sliding is translation. Okay, so that's a word worth writing down. But when we say translation, what we mean is sliding or shifting, and that means moving the graph up or down or left and right. And there's usually two different ways you can do it. You can slide the graph up and down or left and right, and there's two different ways to do that. And if you want to slide it diagonally, you just kind of do an up down combined with a left right. So that's one kind of transformation. Flips are another, okay? And the math word for a flip is a reflection. And this is mirroring the graph either horizontally or vertically. Now, in geometry, yes, you can mirror it over any kind of line you want. And later in Algebra 2, we talk about mirroring or reflecting over the line y equals x. But when we're studying transformations, we mean either a horizontal mirror image, like something like, well, it would be helpful if I got like a pen. So if you had something like this and you were going to mirror it vertically, it would end up looking like that, or a horizontal. So what we'll look at in this lesson is if you have something that looks like that and you mirror it downward. Okay, so that are vertical. So it's like stacked vertically or horizontally. And then dilations. Now, this can mean, this is like a broader word than the word that I really wanted. For Algebra 2 purposes, what we usually are referring to what we are usually referring to there is stretching or compressing. And this is stretching or compressing the graph either vertically or horizontally. So I'll give you a kind of a visual idea of what we mean by that. If you had a circle, okay, now a circle is not a function, but bear with me here, and you were to stretch it vertically, it would end up looking like that, okay? And it's like you're pulling on it in that vertical direction and it's stretching it out. By compressing, it would look something like this because you would be pushing on it vertically. Okay, and so it's easier to show with the circle. Okay, sometimes when I'm in class, I'll use like a hair tie, a rubber band, a hula hoop, something like that. Okay, so that's what we're referring to there. Now, with transformations, there are varying levels of complexity with this topic. So we usually start it in Algebra 2, and then if you move on to pre-calculus or college algebra, you can get into more aspects of it. You can make this more complicated. But in Algebra 2, we typically stick to the following. Basic slides, up, down, left, right. Okay, so can you move the graph left, down, up, down, left, right. Basic flips, usually vertically. Okay, that means over the x-axis. So do we talk about other kinds of flips? Yes, but not very common. Okay, so usually when we say flip, we mean over the x-axis. And a general treatment of stretching and compressing, again, usually vertically. I have taught horizontal stretches and compressions. I know they come up in some other math classes. Those get weird to kind of keep straight. So in Algebra 2, when we're first learning it, we usually keep it to vertical stretching or compressing of the graph. All right, so where do we start? We start with something called the parent function and the parent graph. Okay, so parent, you think of who your parents are. Then you have children. Okay, and so you have the parents, and the parents is the starting point. Okay, and then parents have a bunch of kids. Okay, so the parent function is the simplest function in a family. So we're kind of keeping that same metaphor where we have like a family of functions, and then we have the parent functions, and we have like all these little baby functions running around. The parent function is the simplest function in that family. So for example, for a quadratic, the parent function is 1x squared. And typically we do not write the 1. And so most of the time you'll see the parent function is just simply x squared. That's because you need the x squared to make it a quadratic. Okay, if you don't have an x squared, it's not a quadratic, but we don't have anything else in there other than the x squared. So just the bare amount to make it a quadratic. For absolute value functions, it looks something like this. It's got the absolute value and nothing else. Okay, radical, this is usually covered later in Algebra 2, but you'll get the idea. This would be a square root function, and pretty much it's the simplest thing. So we have to have a square root for it to be a square root function or a radical function, and we don't have anything else. So no positives, negatives. I mean, I guess it's positive. It's positive 1. I mean, positive 1 out front, but we're not adding and subtracting anything like that. So the parent function is usually where we start all of our studies on functions, and it's like, okay, what's the simplest thing? What's the simplest function we can get there? The parent graph is simply the graph of the parent function. So if you go onto Desmos, or you grab your graphing calculator, or you build a table and you graph the parent function, what would you get? So the quadratic parent graph. So what I did here, this is a screenshot from Desmos, and you can see what I have over here for the parent function. So I did put in the 1. Okay, so you can remember that is 1x squared, and we have the table here. And so we have, if we plug in like a -2, -2 times -2 is +4, and there's the point right there. -1 times -1 is +1. There's the point 0, 0, and you can see those points. The name of that graph is called a parabola, and that's the shape of it. So a lot of students will say parabola because they'll be like, it looks like a bowl, as opposed to absolute value, which is pointy. But there's your parent graph. This point right here is called the vertex of the parabola. And it's the turning point. So it's where it goes from going down to up or up to down, depending on how your parabola is oriented. Now, right here, I am going to link something up here. Click that to watch the Desmos demo. It is a required part of the lesson, because once I go on to the next slide, I'm going to assume that you have watched it. So go ahead and click now. All right, so I hope you're back. So we're going to summarize. We're going to go through and summarize everything you just watched in the video. And if you are like, I'm just going to jump to the summary because I don't need to watch, go and watch it. Rewind this video, go pull that link up again, and watch that. Okay, I know you probably don't want to, but like, do it anyway. All right, just do it. Just trust me, do it anyway. Okay, adding or subtracting a number outside the graph slides the graph up or down. And again, if you didn't watch the video, that doesn't mean a whole lot. That big capital outside, like, what do you mean outside? Go watch the video, and demonstrate what it is. Adding or subtracting a number inside slides the graph left and right. And this is the one that is counterintuitive, meaning it's backwards from what you expect it to be. So you expect, positive to go in the positive direction on the coordinate plane, and it doesn't. Okay, so it kind of messes with us. A negative out front flips the graph over the x-axis. So if you see a negative, it will take that parent function and flip it over. If you don't see a negative, it's going to be oriented the same way as the parent function. And a multiplier greater than 1 stretches the graph. So we mean that, like, say, I don't know why that clicked over to like a yellow, but like something like 2, 3, 5.5. Okay, greater than 1, it will stretch it. A multiplier less than 1 compresses it. So this would be something like 0.5 or 0.1 or 0.25. Not necessarily negative though, because the negative does something totally different. So when we say less than 1, what we really mean is this. Hang on, let me not use an X there. What we really mean is the number is between 0 and 1, because if it goes less than 0, then you're dealing with a negative, and then you're dealing with a flip. Okay, so but that gets very cumbersome for us to say. We can also phrase it with the absolute value. It just kind of gets tangled up. So cheat sheet. Okay, so I will give this to my students all the time. Like, this is like kind of your summary, and it assumes that you have gone through the lesson. All right, do not try to start here. That will not work out for you. If you see a negative out front, that means it flips over the x-axis. This number right here is your multiplier. If that number is less than 1, it will compress the graph. If that number is greater than 1, it will stretch the graph. Inside the squaring, if you have a plus, it will go to the left, which is not what you expect it to be. You think, oh, plus, it should go to the right, and it doesn't. And the reason it doesn't is because of that minus sign right there, because there's already a minus sign in there. And if you have a minus, it goes to the right. So I'm going to go ahead and star that. That tends to be what will trip students up. And then this number out here outside, if you have a plus sign, it will go up on the coordinate plane. And if you see a minus sign, it will go down on the coordinate plane. Typically, students are most confident of the up and down, and they are least confident of the compressing and the stretching. And so you might be different. That's just kind of typical, like how have my students like felt about this in the past. But that is your cheat sheet there. Okay, so what directions might you see? The directions for these will typically say describe or state the transformations, which means that your answer is going to take the form of it flips, it goes right 6 units, it goes down 7 units, it is stretched or compressed. Your answer should take that form. You should not be trying to solve something. You should not be writing x equals 3. I mean, I've seen all of those kinds of things in my teaching of Algebra 2. Describe or state the transformation. So here's an example of something that you might see. The answer that I would be looking for, and again, I'm one teacher, your teacher might want something a little bit different, so you're always listening to what your teacher wants. I would accept this, flips, okay, because of the negative. Okay, so right there, it flips. Now, sometimes a teacher might want you to specify that it flips over the x-axis. Okay, typically when I'm doing quadratics, I don't require that because the other kind of flip you can't see. All right, if it flips the other way, or if you do, like it's much messier. So either flip, or you might be more specific, flip over the x-axis. The 2 right there, 2 is greater than 1. So this is a stretch. So I would want my students to write the word stretch. And you might have to include more information, like by a factor of 2. Okay, and again, follow your teacher's directions on that. Like, what does your teacher want you to say? The +3 on the inside, that is going to make it go left 3. So I would want to see a student write left and then how far to the left. And then that -5 is going to send the graph down 5. And so this would have 4 transformations. It's got a flip, a stretch, a left, and a down. And how many points something like this is worth, that's up to the teacher. Some might have it like a point for saying it goes left, and then a point for making sure you have the right number with it. You know, that, again, ask your teacher, like, how will this be graded? Second example there. We've got the 1/2. So I would say this is compressed. And for me, usually that's enough, but you might need to give by a factor of 1/2. Okay, let's say it's compressed by a factor of 1/2. There might be some other ways a teacher might want you to say that, like they might consider compressed and 1/2 to be like duplicate information. So they might want to say like compressed by a factor of 2 if the understanding is that you're dividing by 2. Just again, pay attention to how your teacher wants you to say it or how much information they want you to give. And this one is just going right to. And a common mistake that I see is students wanting to give me more information. So they'll feel like, oh, I've got to tell everything, and they'll tell me it's not flipped. Well, I mean, I don't require my students to tell me if it's not flipped. Okay. Maybe your teacher does, like they want either flip or not flip. Maybe you got to check a box off. I don't know. I've also seen a lot of students try to turn the squaring into a transformation. And so they'll look at the 2 and say, I don't know what that 2 does. That 2 is telling you that it's a quadratic. Okay. That 2 is your tip off of what family it is. It is not a transformation. So you don't want to add that in. Okay, so please don't forget to like and subscribe if you found this lesson helpful. I know it's a longer one, especially with that mini lesson in there, but it is also pretty thorough. Drop a comment or a question to engage, especially there are some things with directions and how you might express an answer. Yeah, like let me know if you got a question. I'll do my best to respond and clarify. And check out the practice set for this lesson. So make sure you get some practice rehearsing this information and working out any kinks. And I hope I will see you in the next video.